Welcome, ladies and gentlemen, to your MN6 notes. This is going to be where we talk about the midpoint. This is section 1.3 in your textbook. Notice the title of your note guide actually has midpoint and distance formula. We're going to focus the distance formula tomorrow on your MN7 note guide. I split this section up into two to make it a little bit more reasonable for everyone. So today we only will talk about the midpoint. And let's talk about just what a midpoint really is. I'm going to draw a line segment here. This is going to be point A. This is going to be point B, let's say. And the midpoint is where you take a line segment and you break it up into two equal pieces. So this, I'm going to say, is M, point M, which is going to stand for midpoint. Now, I'm going to say this. Right now, you can't really tell whether this is a midpoint unless you have notation showing that it is the midpoint. In this case, I have one hash mark from A to M, and I have another hash mark from M to B. That means I can say that AM, line segment, is going to be congruent. And remember, this is a word that we talked about before in New Guide MN3. Congruent means that they're equal parts. So line segment AM is congruent to line segment MB. That's just some notation because obviously as we're going through the geometry curriculum, it's a lot about notation, kind of like communication. I equate it to having a period at the end of the sentence, knowing then that the sentence comes to a conclusion. You know, a comma is creating a breather mark. So it's good notation in math is just about communication. Okay, so this is midpoint. Now the segment bisector, the first thing I want to do is talk about what a bisector in general is. I'm going to actually even bring this word down here because it's that important. Bisector means that you break, in this case a segment, but break in half. So if it's segment bisector, that means if you have a segment, let's say again AB, and in this case, I'm going to put a line through it. And this line hits right here, again, let's say at M, and breaks the segment up into two equal pieces. That means that line is a segment bisector. Again, it's a segment we're talking about, which is AB segment. And bisector means that this line is bisecting or breaking it up into two equal pieces. Soon we're going to talk about angle bisectors, and that's simply an angle that's broken up into two equal pieces. So anytime you hear bisector, just think about that it's being broken in half. Okay, down here, this kind of reiterates the whole definition of a midpoint. If point C is the midpoint, so they're saying, oops, point C right here is the midpoint. These vertical marks, which I call hash marks, but here they're calling them vertical marks, tell us that the segments are congruent. And if you use the word equal here, that's fine. If you use the equal symbol, if you write it out congruent or write it out equal, that's all fine as well. But really, I just need to make sure you remember that midpoint is really the point that breaks the segment into two equal pieces. Oh, I do want to mention, as I'm forgetting up here, the segment bisector, I used a line to segment that or to bisect that segment, but that could also be just a point, kind of like we have here down here where the point C is the midpoint. That's technically a bisector of this segment because it breaks it up into two equal pieces at the midpoint. It could be a ray. It could also be another line segment. So I just want to mention that in case when you see those practice problems, you realize that segment bisectors can be any of those things: a point, a line segment, a ray. Example 1. This is really kind of getting using the definition above of midpoint and using it in some sort of application sense. It says find the length of AM. Now AM is going from this point A over to this point M. And eventually we want to find that length. Now notice over here we have some information. We have that AM is equal to 3x plus 2. So I'm going to put that right under AM over here, 3x plus 2. That expression represents AM. So the green is AM. I'm going to switch colors here and say MB is represented by 4x minus 3. Now, notice again we have this point here, and we're showing that this length is equal to this length. So we do have that M is a line. Okay, so those segments equal each other. So if AM is equal to MB, and 3x plus 2 is AM, and 4x minus 3 is MB, we can say they are also equal to each other. So the segments are equal, so that means the expressions that those represent are equal to each other. So I'm going to bring that over here. And I'm going to solve for x here. So I'm going to subtract 3x from both sides. I have 2 equals 1x minus 3. I add 3 to both sides. I have x, or 1x, equals 5. So this is important because we've just found out that our x value. That is not the answer, though. The answer is going to be what is the length of AM. AM is not 5 units long. AM is represented by this right here, this 3x plus 2. So we need to put the x value back in for x now that we know what it is and find the actual length. So I'm going to just do the work right here off to the side. 3x plus 2. I'm going to go 3 times the 5 plus 2. We have 15 plus 2, which gives me 17. So the length of AM is 17 units long. Now, if you put that 5 in for this x value for MB right here, you would also find that it is 17 because, of course, the M is the midpoint. So each length is 17. Just be careful with the instructions because sometimes they ask different questions. Sometimes they say just solve for x, and that would have been 5. Then in this case, they're asking for the length of AM, which is 17. If they ask for the length of MB, you would also say 17. But if they're asking for the full length of the segment from A to B, that's when you would double 17 and say that it is 34. So 17 times 2 is 34. Okay, so I wanted to mention that because sometimes students need to be told to read those instructions really, really carefully. Okay, example 2, it says find the coordinate of the midpoint of M. Find this coordinate of segment AB. So think of this being as being right on the number line. The A value is 2, the B value is 20, and I want to know what this value is right here if this were just on the number line. And think about it for a minute. I will tell you that many students say 9, and a lot of students say 10. The actual answer is 11. Now, again, the reason why some people say 9 is they say 20 minus 2 is 18, divided by 2 is 9, but 9 would actually fall more like right here. And 10, they say that because half of 20 is 10, but that's assuming you start at 0 instead of this 2. Now, really, if you think about how to get to 11 mathematically, and this is kind of down here, it says, how did we use the coordinates of the endpoints to find the midpoint? What you want to do is you want to add together and divide by 2. And if you think about what I'm asking you to do, you want to add the two endpoints together, divide by 2. That's the same thing as average or using the mean. So we're just finding the mean or average of the endpoints. And if you're not quite sure what I'm saying, I'm talking about 2 plus 20 divided by 2. That is going to give you 11. The reason I bring this up is because this is really essentially what the midpoint is. The midpoint or middle point is the middle mean of your endpoints. And I'm going to show you on the back here of your note guide how that works. So I really can't stress enough that the midpoint is just the middle point or the average central tendency mean of the line segment. So here's a line segment on an XY axis. This is hugely different than the front bottom because we're talking about needing to find the middle point of this. So let me just first give these points. Let's see, we have 1, 2, 3, 4, 5. We have -5, -3 right here, and we have 2, 8 right here. Now I want to find the midpoint. The midpoint is going to be somewhere in the middle of this line segment, which is going to be somewhere in here. Now we don't know where it is. That's what we have to calculate. So kind of like the front bottom Example number 2, all we do is find the averages. We're averaging our x-coordinates. I'm going to focus on the x first. We average our x's, so 2 plus negative 5. So our x-coordinates, 2 plus negative 5, and divided by 2. That's going to give me negative 3 over 2, and that's going to give me negative 1.5. That's going to be the x-coordinate over here for the midpoint. I'm going to call the midpoint M. And so my x-coordinate is going to be negative 1.5, which is the average of my x-coordinates. Now I'm going to find the y. I'm going to add the y-coordinates together. 8 plus negative 3 divided by 2. That's 5 over 2, which gives me 2.5. That's my y-coordinate now. Now let's check to see if it actually makes sense. I'm going to use my red pen here. Negative 1.5 is about right here. I'm going to go up to 1, 2.5, and that puts me right here. That is your midpoint. So the midpoint is just the middle point or the average of your x and y coordinates. Notice I have not given you a midpoint formula. I'm going to do that now, but I'm just letting you know the midpoint formula is exactly what we just did above, which is really you find the average of your x's. So you add your x coordinates together, divide by 2. That will give you your x midpoint. And you add your y coordinates together and divide by 2 to find the y coordinates. So the midpoint formula literally is just saying find the average of your x's and find the average of your y, and that'll be your midpoint. Now example number 4 is just practicing exactly what we just did above without a graph. I'd like you to use the midpoint formula or just your averages to find that midpoint. I'm going to pause the video, you do it, and then from there check to see if you're right. So pause the video right now, please. Okay, welcome back. This right here is how you find the midpoint in example number 4. The work, you should have gotten the answer 5 halves over 5. 5 halves is the x-coordinate here, and 5 halves, or 2.5 and 2.5. You can do it in either fraction form or in decimal form. Either one is fine. But that is the midpoint. All I did was find the average of my x-coordinate, find the average of my y-coordinates, and there we are. Now example 5 is a little different. I want to kind of go back up here. Notice again, finding the coordinates of the midpoint. We were trying to find the midpoint here, given the endpoints. This is different. Find the coordinates of the endpoint, given the midpoint and the endpoint. So here what we have is an endpoint, a midpoint, and we need to find the other endpoint. I do want to say this. In our textbook, they show a very algebraic way of doing it. I found over the years that the best way to explain this is by number sense. And I do also want to say this is the #1 missed question on ACT tests practices when I do them throughout the year because students tend to forget it. So please write these very carefully in your notes because otherwise you're not going to be able to follow it later on when you're going to need it. I'm going to first just throw the 3 coordinates marks down here. And what I'm going to say is this. These outer 2 will be representing my endpoints. So like this is going to be my endpoint. This is my L. So these are my 2 endpoints. And this in the middle is my midpoint. Okay, so I have my 2 endpoints represented on the ends and then my midpoint in the middle. N is given to us as -1.5. The midpoint is given to us as 2.6. What we need to find out is this L point. The absolute easiest way that I have found to explain this is either by graphing. You can definitely graph this and figure it out kind of using the idea of slope, or using this number sense. Let me show you what I mean. Think about going up a stairs if you want. Well, you're starting at -1 and you're going to 2. -1 to 2, you would have to add how many steps? In this case, -1 to 2, you're adding 3. Well, if that's the middle point, then to get to this next endpoint, to make sure that these are equal in length, you'd want to add 3 again. So you want to do whatever to the first to get to the second, and then do that again to get to the third. So -1 to 2, you add 3. So 2, if you add 3, will give you 5. So -1 to 2, 2 to 5. If you think about 2 is right in the middle of -1 and 5. Now I do the next one, the y-coordinate. The y-coordinate to get from 5 to 6, it's a jump of 1. So if you jump 1, then you need to jump 1 again. So that is the trick, is just making sure that you have constant a pattern here as far as making sure you're moving up the same direction. Now, it could be moving down. You could be subtracting 1, and then you would just subtract 1 from the next one. So again, let me just say this again. 5 to 6 is adding 1, so 6 plus 1 is going to give you 7. So the midpoint here, or not the midpoint, I'm sorry, the end point, L, is going to be the point 5, 7. So it's as easy as using number sense and noticing what the movement is and just being consistent with that movement. Okay, so thank you for tuning in. If you have any questions, I'll answer them tomorrow in class. Take care.